It still says waiting.
Late. All right, technical difficulties. Oh, there we go. It is now.
Oh yeah, there we go.
Dying. Yep.
Yeah, our audio is going through it, by the way.
Fantastic. Okay. Audio is going through.
It's been for several like the stream. I have.
Yes.
There's a big lag though.
Okay, are we ready for me to share? Read. Fantastic.
All right. Hello and welcome to the 2020 Cyber Defense Club Fire Hose meeting. This is our new members meeting, so this is where we take you people who are new to the club and don't really know very much about what we are or what we do, and we kind of show you what we do and how we do it, and hopefully get you to the point where you're going to feel comfortable kind of talking about what we do and getting experience starting next Thursday when we see you for our first club meeting. It's going to be at the same time, 6 p.m., and it's going to be held on our Discord server. Just a quick kind of introduction to how this is going to work. We're going to go and have 3 different presenters, and we're going to all present about some stuff, and then we're going to give a brief break in between each. You can ask questions You can ask questions in the YouTube live chat. You can also ask questions in the Discord general chat. We'll have somebody who's reading those, and then they'll read them aloud to us on the stream, so we can answer your questions there. Just so you know, there is about like a 30-second delay, so if we're not getting to your question immediately, that's why. That's just about everything. With that, I think I'm going to kick it over to our first presenter, Scott Packers. Scott, if you.
There we go. Now you can hear me. Amazing. We've seen everything. Okay. Hi, I'm the SEO, Safety Unix Officer for this year. You do Josh, Brianne, and Joy for helping with these slides and making them previous years. Quick outline, we're going to talk about safety first and then ethics. Hopefully I'll make it a little bit of fun. Safety. With COVID, we're going to be meeting online entirely. If you are online and you're sharing your video, drinking, follow K-State's guidelines for meeting online. Availability. So confidentiality is okay. The safety one or this one? Here. Okay, safety, again, we're meeting online. If you're going to drink, be discreet about it on video chat, and then follow K-State's guidelines on COVID-19 so that we can end this plague. For the CIA triad, it's a key concept in security, confidentiality, integrity, and availability. So confidentiality is keeping information available to those that are authorized see it, and those who aren't authorized not being able to see it and access it. Integrity is maintaining assurance and assuring the accuracy and completeness of data over its life cycle of use. And availability is for systems to be able to give information that's available when needed. And this also can apply to users being able to reach online, such as making sure that our live stream is live at 6. To cover for if we come back during spring, food has to be handled properly. And then alcohol policy, no open containers and vehicles if we do get the chance to drive to any competitions. Now we're going to move over to ethics. Primary, so some general advice to follow if you're not sure about things. Instead of just hacking away at things, ask for permission. I prefer more do's than don'ts. It's always annoying to be told, no, you can't do a thing. So here's more do's again. Use security tools safely and respectfully. User infrastructure, we'll talk about that more next week. Share information with others and questions. If you don't know something, Google it and ask your friends and us in the club. When it comes to don't break or damage stuff. Don't break the law. More obscure thing, don't depend on forgiveness for asking for forgiveness. If you ever do break a rule or law, you're not, the chances of being forgiven are fairly low. And don't be toxic, allowing us to ask them questions and be comfortable around each other. What else am I missing? Yep. Security tools does not include some random exe that you installed. I'm talking actual tools, whether it be Ghidra or not Merobytes, other tools. Our goal for you guys is to be white hat hackers instead of black hat hacker. The term white hat is actual security researchers and red team, people who are employed by companies to find vulnerabilities. Black hats can be any illegal hacking. So there'd be an invasive persistent threat like evil nation state working with them to try and cause misinformation. It can be a single hacker, maybe. The main thing for black hats is that they work for personal gain, and with the end goal of with white hats, what you're doing is legal, oftentimes having permission, or most times, and your ultimate goal is to secure others, whether it be a company or individuals. So going over being with sharing responsibly, we have responsible disclosure. If you discover a vulnerability, first step is to confidentially and privately disclose the vulnerability to the system owner, whether that be a company or the owner of a single blog. You need to make sure that you privately tell them, hey, here's this vulnerability that I found. Here's the way to replicate it. Oftentimes, you'll do a white paper on this. And you shouldn't disclose publicly until the owner is given every opportunity to fix the issue. Typically, I believe the minimum is 6 months, but I could be wrong there. If you don't, then cyber criminals or black hat hackers will have the chance to exploit these vulnerabilities much faster and possibly hurt. For case-based disclosure policy, if you find or suspect a vulnerability, contact the CISO, or if not, the CIO. Follow the same disclosure methods as with other vulnerabilities. So, fantastic. Okay. So prohibited actions affecting others, viewing, copying, altering, transmitting, or destroying files without explicit permission from that individual. Representing yourself as someone else, obstructing others' work, and using other or computer resources for unauthorized monitoring or regular communications. A fun example is if you try to use our infrastructure to try and mine Bitcoins, we have the legal ownership of it. You don't get the bitcoins at the end, and we'll kick you off for our system and out of the club. Don't miss people. Overall, just don't miss other people's stuff, and don't hinder their progress. Included with. Wait, sorry. Okay. If you think there's a vulnerability with K-State, don't try and poke it and move around or do anything. If you attempt to make yourself an admin or anything, you'll be breaking rules and can be liable to losing your account and possibly even being kicked out. So don't do it. Of course, don't introduce any viruses or destructive software. And don't share software and hardware with unauthorized users. Don't share it with your brothers or sisters or family members and whatnot, or friends that don't go to date. Okay. Don't try to bypass any K-State security systems. So it's not acceptable to make, distribute, or use unauthorized copies of license, intentionally distribute or damage others' files, software, or data, destroy excessively damage equipment, and summary of people's property, both intellectually and physically. Don't and steal stuff online. And if you think you can get away with it, go and read all of these different legal acts and legislations. Basically, if you do something, the U.S. knows. I personally have a friend that works with a three-letter agency, and they do actually watch for specific actions. And if they start seeing it, they can quickly find you. And at best, you'll be kept on a list. At worst, you'll possibly end up in jail or have to deal with three-letter agency workers face to face. If you haven't heard them, the 10 Commandments of Computer Ethics are fairly generic once you actually read them. I'm not going to waste your time reading down the list. Hopefully you can read. You are in college. I'm going to give you here about 10 seconds to go ahead and read through them. Maybe I'll open up for here. All right. 5 seconds. All right, moving on. And just to clarify, just because something isn't on these slides, it doesn't mean it's legal or ethical. So here are our sources on disclosure, acceptable use, our 10 Commandments, and the use legislation. Sorry for the misorder with the US and 10 Commandments. And some additional sources. Here we go. Are there any questions or things I need to clarify? Hello? All right. Okay. Yep.
Yep. All right. Let me know once you have it pulled up. There we go. All right. Cool. Yeah. So we're gonna run into kind of the meat of the fire hose, which is networking. So these slides are based on slides by Richard Petrie, Caleb Fleming, and Logan Pro. So thank you to them. Bonus points for those of you that have been around long enough to recognize some of those names. All right, cool. So who am I? My name's Josh Reese. That's a picture of including me on the side there. You probably won't see me on campus just because of all the COVID restrictions and all that. But yeah, so I'm a former safety and ethics officer. I'm the IT manager for Collegiate Media Group. I've done incident response and network security at Paycom 2 summers ago. And I've been to many competitions and done some red teaming as well. The reason why I'm giving the presentation on networking is because I probably consider myself the networking subject matter expert as well as logging for the club. So we're gonna roll right in here to, oh yeah, Hunter in the chat saying he recognizes the names. We'll roll right in here to the 7 layers of OSI. So for these, the OSI model, you'll see it kind of shown like this. It is used to teach networking a lot, but in practice, it isn't super accurate, but it is helpful to understand different parts of the network and how your data is treated when moving between those different parts. And so we're going to talk about these main pieces. So besides this, let's see. So we've got the physical, which is the lowest one. If you see down here on the bottom, it's pretty small, but we've got the physical connection, and that's like the cables and the network interfaces that you actually like plug in. We've got the data link layer, which is layer 2, you'll hear it called. And that uses media access control, or how you'll hear them called pretty much everywhere, is a MAC address to refer to, to transfer your packets and all that between hosts. And so that is used on your local network. But then above that, we have the network, which is layer 3, and that moves packets. Moves packets from source to destination. And that does include multiple hops and getting all around there. Let's see. Somebody had a question. Define OSI. Yeah, it is Open Systems Interconnection. Yeah, it looks like Alexander got that right. So, and then so the next one we'll talk about here is layer. It's the next layer, which is transport layer. And that has some protocols associated with that. So, the cool thing to note is what happens is you have data that is encapsulated, and so data we often call packets. And as you move between those layers, what will happen usually is headers will be added on, and so you can see. And this is kind of, if you flip this over. And it's like as you would move, I'm going to go back the slide. So as you moved up, it would, add, well, actually, yeah, it would add and remove, packets there, not packets, headers for your packet. And so you can see all the different kind of the layers here. So we have the application, transport, and all that. So, protocols are the standards for communication over the internet. It makes it so that you can plug in your computer and it can talk with everything else without having to figure out what way other people are talking. It's a standard. And so the main ones we have are transmission control protocol, user datagram protocol, otherwise known as TCP and UDP. and then Internet Protocol. This also reduces complexity because you can use multiple of those standards and all that, and for each for its specific task. For some of those layers, here are some protocols. So if you're going to google.com and you want to search something, you're using HTTP or HTTPS. And so, that is considered application layer, but that also is on top of TCP, which is on top of IP, which is on top of Ethernet. So they all kind of stack on top of each other and make everything work there. So we're going to talk about that layer 3, Internet Protocol, which is on layer 3. So this handles addressing, and it routes data from your source to destination and back. The data, as I mentioned, is commonly referred to as packets. This by itself, Internet Protocol, does not care about your data in terms of reliability or data integrity. It does not care if it gets, screwed up along the way, and is corrupted or anything like that. That's things that go on top of Internet Protocol that care about that. We'll talk about those. And there's effectively no alternatives. This is what you use. Everything pretty much points to IP here. You've heard me mention addressing, and then you've also probably heard of IP addresses before. So those are it's a number that is assigned to every network interface on a network. And so there's two different types. There's IPv4 and IPv6. The IPv4 is a 32-bit integer, and IPv6 is 128-bit. And then those bits are divided into network bits and host bits. And so then the network bits divide a network into different subsections, which are known as subnets. And then the host bits identify a specific device on that subnet. And we'll kind of talk about this here with an IPv4 address example. So you'll see what we have here is a 192.168.1, .1.172 address. And as you can see, then we have this /24 at the end of it. That's what is called CIDR notation. It's written CIDR notation, and this /24 is the subnet mask. And that means, so as you can see here, this is the address in binary. So 192 is equal to that. So /24 just means that the first 24 bits here, so this first 3 sections of 8 or octets, are all network bits. And so if you change, this to a 1, you're on a different network. Whereas if I change one of these host bits, which is in red, then you're on the same network, but you're at a different IP address on that network. It could be a different host, or it could be open and you could just use it. So yeah, you can also see, so CIDR notation is the /24. There's also decimal notation here, which you'll also see, which is the 255, 255, 255.0. The 255 is just what you have when you put all ones down. And so that means that all of these here, that's 255, that's 255, that's 255. And then that's a 0, and so those are all host bits at the end there. So, and this does kind of translate over to IPv6. I won't really hit on that much. IPv6 is just super long, and we will likely never run out of IPv6 addresses, because again, what was it? 32-bit IPv4 versus 128-bit. Yeah. It is much longer, many more combinations. But in theory, it's the same with those network bits and the host bits. And you see here, instead of 24, it's like /120. So we're going to move on to routing. So what happens if you want to talk with something on a different network with those different network bits? So this uses that layer 3 doing networking. And so your local computer can only talk directly with things on the same network you're on. It doesn't know directly where Google is. So if you want to go to Google, you have you type in Google. It is going to go to your computer is going to send that traffic to what it knows as its default gateway. And so that is if you're at home, it'll be your router that knows. It's like, okay, yeah, so I can get to Google, or I know they themselves have another default gateway that it can send it up to eventually get to Google. There's a lot of different protocols that can be used to do all that routing. Those are kind of cool to get into, but I'm not going to get into them in this presentation. So, but yeah, you have your host and then the router, which should be the default gateway for your computer. And so yeah, if the router doesn't know exactly where it is, then it will send it up to a router that it knows. And then if that router doesn't know, then it sends it to another one. It kind of just all runs like that. And so it works, and it gets your traffic to where it needs to go. So when I mention that Internet Protocol does not care about reliability and data integrity, this does. So this is Transmission Control Protocol, which is TCP. And this is a reliable, stateful delivery of your packets. And so it is going to try its best to get you all the data and make sure none of it is corrupted, and make sure you have all of it and didn't miss one packet, and then all of a sudden your data is screwed up. You don't have it all. This is built in a way that you will get all the data, and you can make sure it's all correct. So one downside is there's some overhead with it, and then yeah, it's often used. Pretty much most things use TCP unless there's a reason not to, and there are certain reasons, and I'll get to that at the end of when we talk about UDP. But first, let's talk about kind of how TCP works. You establish the connection with a three-way handshake, which is on the next slide. We'll mention that. And then the packets are numbered, and the recipient knows and sends back and says, this is the last packet that I got. And then this also has ports. And then if you have in your classes kind of done state machine stuff, this is a finite state machine. So this is the handshake here. So your computer will say, hey, I would like to connect. The server will say, yeah, cool, I acknowledge your connection request. And then your computer will say back, it's like, cool, I acknowledge your acknowledgement of my connection request. And then you kind of, it's more complex than that, but there's other stuff going on. But that's the three-way handshake. So pretty much the alternative to TCP is UDP. And so the main difference is with TCP, it makes sure you get all the packets. With UDP, it doesn't care if you get all the packets. It does also have a port number, so there's some similarities there. But while UDP does not care if you get all the packets, it cares if the packets you get are corrupted or not. So it includes a checksum to make sure they aren't. And this is used, a lot because it's extremely low overhead. You don't have to do much. You don't really have to do all that handshake and stuff. You just throw data at somebody, and hope they get it. One of the main examples that I've heard people say for UDP is just like the stream you're watching. You probably don't care if you get, and YouTube doesn't care if you get frame number 5102 from this stream, because the most important thing is getting the most up-to-date and current frames and data so that you're up to date on the stream. So that's a good example where they would use UDP and not TCP. So if I could sum it up in one slide, TCP would kind of be, you're drinking water and drinking it normally, and if your mouth gets full, you can stop drinking water. With TCP is just like throwing water at somebody and not caring if they get any or not. So that's a good analogy there. And then I think I've got a few slides left, just some basic ones. This dynamic host configuration protocol, DHCP. If you had never seen an IP address before tonight, you have DHCP in part to thank for that. It used to be when, like a long time ago, before I was ever really into computers, like you would hook up a computer and then you would have to talk, like if say you brought your computer to the dorms, you would have to then go talk with somebody and say, all right, what should my IP address be? What should the router that I talk to be? And what DNS server should I look at? We'll talk about DNS next. And so what this does is when you connect to a network, your computer automatically just kind of yells out to everything else and says, hey, I need configuration. Somebody give it to me. And so what happens is your router, or you could have a separate DHCP server, but for most people, it's going to be their router, will sit there and listen for those calls for the configuration, those broadcasts. And then it will say, oh, hey, yeah, cool, you're going to use this IP, this gateway, and this DNS server. So there's no actual, contact. You don't have to go ask somebody what to use. It's already provided there for you, and the DHCP server manages it, and it's pretty fast there. So that happens like every time you connect to the campus Wi-Fi, all that. It is doing DHCP requests to get an address and get all the configuration that it needs. So the last thing I have in terms of networking is DNS. So this is domain name system. So I don't know anybody who ever has done, memorized IP addresses to get to like Google or something, because that's not how it works. What you do is you just type Google and it works. Well, that's not how it works on the back end, because your computer doesn't care that it's google.com. It cares it needs the actual IP address to actually get the data where it needs to go. So what happens is we came up with this system called DNS. And so what happens is when you type google.com, or in this case, it says foobar.com, your computer will then send a query to a DNS server saying, hey, where's that at? And so then the DNS server will either know immediately, maybe because it's cached, or maybe you're just trying to find something that it already, it has a record for on the local network or anything, and it'll respond. Or what's most likely, or what is likely, maybe not for Google. Google probably stays cached quite a bit, but if you're trying to get to some random website that nobody's gone to that that hour or anything like that, the DNS server won't have it cached, and it might not know where it is. So it'll have to go to an upstream DNS server. So your DNS server asks another DNS server, which might go ask another DNS server, until it gets to, it might get to the DNS server that's in charge of the entire .com, area. And then that finally can kind of point you down towards other, other DNS servers to eventually figure out, oh yeah, the IP for foobar.com or google.com is this. And so as soon as your computer gets that response back, which happens pretty quickly, that then your computer can go on ahead and it knows where that web server is now. And so it can actually send its request to the right server because it knows the IP. And it's using that IP to send that request, and then you get a response back. So, DNS is it can often mess up and cause some issues, but it is the thing that makes sure we don't have to memorize IP addresses, and it's pretty great. So, that's all the networking stuff I have. One other thing I don't think I mentioned, I'm one of the assistant system administrators for the club. And so we do, I think Scott mentioned kind of our infrastructure. If you're interested in that, we will not be having signups tonight. We will send that out, a link to kind of sign up sometime next week. Probably early next week. We're hoping to probably have it done, by the next week's meeting. But yeah, we'll get that available. We'll send that out through Slack, so you guys can sign up. And we've got a lot of fun things that you guys can do. You can build your own networks, and it's live fire, so you can attack other people and be attacked and do all that. It's probably one of the coolest things we have. So. Other than that, that is all I have. So I'm going to hand this back to Ian.
Yeah. Thank you very much. I think we're going to wait just a little bit for some questions, if we have any from viewers. Otherwise, I think it's my turn. So we'll give that just a sec. Yeah, while we wait, I think a fun little anecdote about, you mentioned IPv6 is a lot bigger than IPv4. I think, if I remember correctly, IPv6 is designed such that you could give every single atom in the known universe a different IPv6 address, and you'd get like 3/4 of the way through, or something like that. It was designed to fix the problem of us running out of IPv4 addresses. So yeah, there's a lot of them. There's quite a lot of them.
Yeah, because every single bit you add, you multiply the amount of addresses you have by 2.
Mm-hmm.
So it's an insane amount. Yeah.
The other thing I would add... Oh, you go ahead, sorry.
No, go ahead.
The other thing I would add is, if you heard anything Josh just said and you were interested in that, there's a YouTuber called Network Chuck, who I will send a link to in the Slack after this. He does an absolutely phenomenal series starting from like bits and bytes all the way up to like actual networks. Josh, we have a question. Is IPv4 still used more often than IPv6?
From my perspective, yes. I don't think I've ever seen anyone using IPv6.
Mm-hmm.
Not to say it isn't used. There are some interesting things with it, and some. I know there's some attacks that have used some of the quirks with it, such as when you're using IPv4, in order to reduce the amount of like public, IPs, so that those are things that are publicly routable. That's not like your home computer. Nothing can. Most likely you can't type in the IP address of your home computer and get to it.
Let's hope not.
I hope not. Yeah. So yeah, what happens with IPv4 is you have network address translation, and so that essentially your router, which has a public IP, maybe might have a public IP, that will essentially assume your internet traffic as its own, and so it will like rewrite it kinda, so that when it leaves your network, whatever it's like, if you want to get to google.com, your router will replace that address, that source address that you have on there, with its own public address, so that Google actually knows where to send the data back to.
Mm-hmm.
Otherwise it won't. So that's kind of interesting. But with IPv6, you don't need NATs because there's so many addresses. So it just yeah. So there's if you like, I think there's been attacks where people have maybe set up IPv6 kind of, but then not really, done much with it, but it's still active on a system, and maybe that's a way to get around a firewall or some adding if they don't take that into account when they're making firewall rules or anything like that. So it's something interesting, but not something I've really done much with.
Yeah. Well, thank you very much, Josh. I think I'll go ahead and get started on my next presentation, or on my presentation. The next presentation, my presentation, and talking's weird, huh? So I'm going to do two presentations. I'm going to talk about Linux and also an intro to web app pen testing. And so before we start talking about Linux, I kind of want to talk about operating systems in general, because you probably are most familiar with either macOS or Windows, and those are very useful operating systems for a user, but sometimes they can be a bit annoying when you want to use it for something else, particularly like servers. You can run those as servers, but sometimes they aren't perfectly suited for that. And so in the world, a very large portion of servers, like web servers, anything you interact with, those run Linux. So a brief history of what that is. So to talk about Linux, we have to talk about Unix. So what is that? Well, there was trouble in the early days of computers. And when I say early days, I mean like 1960s, 70s-ish. The thing was, software was not written in a programming language as we would generally think of today. It was written in assembly, right? Which means like individual instructions for the processor to run, which means porting an operating system from one physical hardware to a different hardware on a different machine was really, really troublesome. You could keep a lot of the same concepts, but you really couldn't keep that much of the actual code that would move over. And that was the case until about 1970, when a group of engineers at Bell Labs were tasked with creating an operating system for the PDP-7 machine, which is that big bookcase of a computer over there. That was, at the time, a relatively compact computer, to show you how far we've come. And they said, well, hey, why don't, instead of writing it in assembly, why don't we write it in C, which is, generally speaking, one of the first, what we would call like a high-level programming language. And so they wrote the operating system for that machine, and they called it Unix, and it worked really, really well. And the cool thing about writing it in C, in a high-level programming language, is that you can run that code on any physical, or on any hardware, I should say, so long as that hardware has a compatible C compiler, which kind of blew up because no one had ever really done that before. They had written one operating system that could run on, with, I mean, obviously a few tweaks here and there for different hardware, could run on basically anything. And because of that, it was massive. Like, it was the first widely used OS. It was pretty much the only thing that anyone used for a good long while there. So that's Unix, right? Smash forward to 1984. This gentleman in the top right, Richard Stallman, is having trouble getting his printer to work. It doesn't work exactly the way he wants it to, and so he calls up the people who make the printer and say, hey, I don't like your software. Can you give me the source code to your software, and then I'll just fix it, and then I'll execute it on the printer, and then like my printer that I paid for will work as well as I want it to. And the people who make that printer said, no, you can't have that, which really ticked him off. He thought it was absolutely ridiculous, because why is it that we are constantly reinventing the wheel as programmers, right? If someone's already written printer software before, and someone makes a new type of printer, why do they have to write printer software again? Why can't we just make the common printer software that most printers use, and that'll make everybody's life easier? So Richard Stallman creates the Free Software Foundation in 1984, which is designed for that exact purpose. It's designed to make software free and more common and open source. And they did a lot of really cool work. They created Emacs, which is a very popular text editor. They made GCC, which is a very, very common C compiler, and a ton of stuff. And at a certain point, they thought to themselves, well, if we're making all these tools, why don't we just make our own operating system? I mean, we were like 80% there. We just need a few extra things to kind of patch them all together, and then we're fine. So they decided, yeah, we're going to make an operating system that looks and feels like Unix, but it's not Unix, and we're going to call it GNU. And a fun sort of trend there is what are called recursive names. So the G in GNU stands for GNU. The N stands for not, and the U stands for Unix. So GNU is short for GNU is not Unix. And then the G in GNU that stands for GNU, and then the N in that stands for not Unix, and then the G in GNU stands for GNU, and blah blah, and it goes down infinitely. It's a fun little quirk. It's pretty common in programming names or just like tech names. But so they decided to make GNU, and they had this trouble because they couldn't get the kernel to work. And if you don't know, the kernel is the thing that keeps kind of all your hardware working together. It's what lets your speakers and your keyboard and your GPU and your CPU and all that stuff interact seamlessly in a way that other software can work with. And they worked on it for quite a while, and they couldn't really crack it. Until 1991, when this gentleman, Linus Torvalds, who I've just now realized I'm covering with my webcam, so I'll block myself for just a sec. This gentleman here, Linus Torvalds, creates what he calls a project that he calls Linux. Again, that's a play on his name Linus and Unix, right? And so what he does is he creates the Linux kernel, which is the missing piece that GNU was missing, and he takes all the GNU utils and mashes it all together into a single project and creates GNU plus Linux. And that is the first like working open source operating system. And immediately it went gangbusters because it was Unix, but it was A, free. You didn't have to pay Bell Labs for it. And B, if you had any problem with Unix, right, you could just fix it in Linux. You could just have your own version of Linux that works the exact way you want it to. Really quick note, there's a bit of a naming convention problem with this. So the official name for this operating system is GNU plus Linux, but a lot of people just say Linux for short. So for my purposes, I will use those terms interchangeably. I know they are technically not the same thing. It's fine. We're going to move past it. So, like I said, Linux spawned off a million little micro tweaks of it, right? So those little different spin-offs are called distributions. And so this here is a graph of distributions. In fact, it's so massive, I had to cut off the entire bottom half of this graph because I couldn't fit it all in one screen. But so, for example, right, Debian is an incredibly popular Linux distribution. And so it was started in what looked to be like 1993, right? So it went from 1993 until 1998, when you had a couple other spin-offs here, a couple other spin-offs there, Lindows, Linux, right? And it keeps going until we reach Ubuntu, right? Here in 2004. And then that spins off into Kubuntu, Xubuntu, all of these, right? Ubuntu is probably the most popular. I don't actually have numbers for that. My guess would be the most popular Linux distribution at the time. But yeah, all of these, and they're all just slightly different from each other enough that you can notice it. But why do we care, right? Well, I said at the beginning that a good portion of servers run Linux. That number is actually kind of hard to hammer down what percentage of servers worldwide run Linux. From the research, from the articles I could find, I could see anywhere from 60 to 70%, depending on what year you're looking at. But I think 67% is my current best guess, although that number could be wrong. Approximately 67% would say. So 67% of servers on the internet run Linux, right? So obviously, if you are a part of a club that is interested in making things on the internet secure, it's very important that you have a very fundamental understanding of Linux. And so, with that, I'm going to jump over to a different display and do a brief demonstration. So one of the really cool things about Linux is it is designed from the ground up so that you can do everything through the command line, which is really, really cool because if you need to connect to a remote server, the network traffic between you two is really simple. It's literally just text being sent backwards and forth. That does cut out a little bit of like understandability and usability, but I would argue that once you truly get to understand how that works, you will prefer to do things over text rather than visually because it gets to be, if you get to be efficient at it, you can do it very, very quickly. So what are we looking at? What you're looking at is a terminal, which is just a visual application that allows me to interact with the shell running on my system, right? A shell is the actual code that handles the interactions between the operating system and the user. So my terminal is running the bash shell. Bash, which stands for Born Again Shell, is probably the most default shell there is in the Linux world. It's very, very common. And so that's what we're going to be looking at here. So this is a bash shell prompt. So first off, what are we looking at, right? So the first things first, this right here is my username. And then it says @ and then the name of my computer. So right now I'm logged in as Ian at desktop. And then there's some extra information here. We'll get into that in a sec. And then just a blinking prompt that says, okay, go ahead and interact with me. So again, you interact with this entirely through text, right? So what I do is I give it the name of a command, which is just a program somewhere on my computer, and I hit enter. And what the shell does is it goes and it finds that program, it executes that program, and it returns what that program did. So I said date, which is the command you use to find out what the date is, and it returns the date. If I wanted to create a file, the command touch does that. But touch doesn't know what the name of the file that I want to create is. So I have to tell it with an argument. So file, we'll say file singular, file.txt, right? So I run the command, I give a white space, and then I give it a parameter. And I hit enter, and that file has been created. But we don't know that it's been created. Like, we can't see it. So how do we double check that it was created? Well, if you want to list all of the files in your current working directory, you type ls and hit enter, and you can see file.txt. You can also see my pictures, my downloads, and my documents file. But I just said something just then. I said my working directory. What is that? Well, it's important to understand that when you're interacting with a shell, you're always in a directory, basically no matter what. If you want to know what that directory is, then you type pwd, which stands for print working directory. And I hit enter. And I can see my working directory is the directory named Ian, that's inside the directory named home, that's inside the root of the file system. If I want to change my working directory, I use cd, and I change to, let's say, downloads, right? Quick note, this little / here is just a bit of shorthand to say I want the downloads directory and not the downloads file. You can have a downloads file here as well, and that's how you specify the difference. So I'll change directories into downloads, and I'll hit enter. And now you see that this little prompt has updated where I am. Again, we'll get back to what that tilde means. But now it says I'm in the /downloads file. And if I run pwd, you can see that I'm no longer in home Ian, I'm in home Ian downloads. If I don't like being in downloads and I want to leave downloads and go back to where I was, go back up a directory, I can press cd ... which means for change directories, up a directory. ... isn't a real directory. It's more of like an alias. That means up one level in the tree. So I hit enter, I hit pwd, and there I am back at home. The directory you start in when you log in is called your home directory, and it is shorthanded for this tilde, right? So if you want to change, no matter where you are, if you do change directories tilde and hit enter, oops, well, if you don't do a weird tick there, tilde, it will bring you back to /home/Ian. Also, it's important to note that this line right here, this is called a path. A path is basically an address a specific address of any file or directory on the file system. So if you start at /, which is the root of the root of the file system, you can access any file on the entire computer. So for example, if I want to be specific, if I wanted to remove this file.txt, the command to do that is rm and then file.txt. So it's saying remove, and then I'm telling it the name of the file that I want. And since I only specify a name, remove just, if I were to hit enter right now, remove would assume, oh, he means remove the file in his current working directory. But let's say I don't want to do that. I want to be very specific which file.txt I want. I can give it my global path file.txt, right? So if I start at the root directory and I give every single folder all the way down to the file I want to delete, that's called its global path. Because no matter where I am, I can always reach file.txt with this. But if I change directory into downloads and I try to rm file.txt, I can't, because file.txt is not in my working directory. But if I try to rm/home/en/file.txt, enter, then I can delete it. I'll go up a directory and ls, and you'll see it's gone. Oh, and you can also hit clear to clear your screen. Like the most useful command in all of Bash. I do it all the time. Really quick, a few more things. So I did a lot of commands like this, right? So the way of passing information into the command is command space and then a string. That's called a parameter. But there are other types of arguments in Bash. So generally, you'll see something called a flag, which is usually represented as space dash single letter. A flag is any argument that doesn't take a value. So it's either binary, it's binary. It's binary, right? It's either off or on. You either have a -L or you don't have a -L. So when I don't have a -L on ls, I just get the list of all the documents. If I do a -L, it'll give me extra information. So it'll tell me the name of the documents, but it'll also tell me when they were last edited, the person who owns them, and that document's permissions. The other option, or the other type of parameter, is called an option. It's generally used for things that aren't strings or booleans. So like an integer, right? So that's, again, generally represented as / name of option equals value. This syntax is not always the same. Sometimes it's name option, then a space. Sometimes it's something else. But generally, those are the three ideas. So strings come as parameters, booleans come as flags, and basically anything else comes as an option. And then the last thing that I want to talk about with this demonstration is how do you install something with a command line? Because like I said, you can basically do anything you want via command line, but I can't go, if I wanted to install a new program, right, I can't go to, like on Windows, I can't go to the website and download the installer and then execute the installer, because like I can't, there's no Google Chrome, like look at it, how would I open Google Chrome like this? So the way we get around that on a Linux system is we use what's called a package manager, which is a really, really crazy cool kind of thing that is not anymore. It recently, ever so recently, Windows has added one, but it was pretty much exclusive to like Linux type systems up until recently. But so the way a package manager works is you just run a command and you tell it what you want to install, and then when the package manager executes, it goes out to a bunch of official Ubuntu servers and says, hey, do you have this package that I want to install? And they'll either say yes or no. And when you find one that does, you download it and you put it on your machine. So the default Ubuntu package manager is called apt, right? So you run apt and then you give it the parameter install. You can also remove things with apt, but you say apt install, and then you tell it what you want to install. So I want to install this application called Cowsay. And then you hit enter. And you'll see I have errors. You'll see I have permission denied, are you root? When you install something on Linux, you install something for the entire machine. So every person who logs in has access to a version of that executable, which means if you can install stuff, you can install some malicious stuff. You can do it, a lot of stuff, basically. So what they do is they lock the ability to install things behind the root user. The root user is the most powerful user on the entire system. The root user can do literally whatever it wants. But it would be kind of a bad idea to just give a bunch of people access to the root user. So the way we get around that is we use a command called sudo, which is short for super user do. And what it does is it will take an argument and it will copy all of this and just completely copy it and then say, hey, root, can you run these commands? And root will say, yeah, I can run those commands, and then give them back to you. In order to use sudo, you have to A, be in the sudoers group, and B, know the password of the user you're logged in as. So I'm in the sudoers group because I'm an admin on this system. I'll hit enter and it'll say, give me your password. I'll type, oh wait, I'm typing in the wrong password. I'll type in my password and you'll see nothing's happening. That's because in a lot of systems, when you type in your password, it's like a bunch of stars or a bunch of dots or something like that. The way Linux does that is it just doesn't show you your password. I promise you, it is taking the input, it's just not showing it to you. That is a very common like day one question, and don't feel bad. I had to Google it the first time I did it. It's not super intuitive. I think I may have typed my password wrong. Yeah, I did. It's hard to talk and type at the same time. Oh well, this is certainly embarrassing. Wait. Oh, thank God. Okay, so what it's doing is you can see it's saying I'm going, I'm looking, I'm finding an application, I'm downloading the application, I'm installing the application. And it installs the application. So let's say you've just installed a new application and you want to know how to use it, right? The most useful command in all of Linux is man. Man, short for manual. You can take basically any command on the entire system and you can figure out how it works just by typing man and then the command you typed or the command you want to know information on and hitting enter. And what it'll do is it'll bring up this man page and it'll give you the name of the name of the thing. It'll give you a synopsis, a description about what it is, and then all of the possible flags. And if I can go down, come on, it will normally give you a list of all the possible. Oh, this isn't giving it. Let's do ls. It'll give you a list of all the possible flags and options and parameters you can give and what they do. Very, very, very useful for just finding things out. If you're ever bored, I think there's an application you can install called Man Roulette, which will just pick a random man page and let you read it, and it's a really good way of like increasing your Linux knowledge. Very highly recommend. But I've installed this application, and I'll go ahead and run it for you, and we'll see what it does. And so it shows a little cow, and he says, hello, CDC Firehose. And that is the end of my little Linux presentation, if you will. I'm going to go into basic web app hacking in just a sec. I'm going to wait for questions and move on from there. All right. I'm not seeing any questions. Still feel free to ask them if you have them, and it's just a bit of a delay thing. But for now, I'm going to head on back to my presentation. So, web app pen testing, sort of the basics. This is a presentation by me, but I do want to say very, very, very... Oh, I'm I'm just now seeing the. That's strange. My phone wasn't updating with the chat. Sorry. Anyways, very, very, very big thank you to Ipsec on YouTube. All of these screenshots come from his video. He's an absolutely phenomenal resource. If you want to get into red teaming or like white hat stuff or just like offensive anything, just go watch his stuff on YouTube. If you have like 45 minutes to kill, he'll take you from not being able to access anything on the machine to being a root user on the machine. And so this is kind of an annotated version of one of his videos. So with that, let's talk about the scenario. Let's say we want to hack into a machine and all we know is its IP address. How do we start? Well, depending on who you ask, there's somewhere between 5 and 7 steps to attacking. I think about 5. I think about these 5. But if you ask someone else, they might give you a different 5 or a different 6. But they'll generally all kind of follow the same format. But these are the ones that I use whenever I'm trying to hack into something. So step 1, reconnaissance. Step 2, initial access. Step 3, privilege escalation. Step 4, persistence. And step 5, pivot. For the sake of time today, we're going to be skipping persistence and pivot. Not that they're not important. They're very important. But for our purposes, I think we'll go ahead and just move right past them. So let's start with step 1, reconnaissance. We have an IP address. What do we do with it? So the first thing we need to find out is what kind of server is it. So we use this command. We use nmap, a couple of its flags. I'm not going to explain what they are. And then we give it nmap the IP address. And what nmap does, nmap is short for network map, what it does is it goes out and it finds all the ports that server is running on, and it finds out information about those ports, and it returns them, right? So we run this, and we see this server is running port 80, which is an HTTP server, and we know it's Ubuntu, and it's running this version of Apache. So we know it's running a website. Let's go see what that website is. And the website says PHP Bash. PHP Bash helps a lot with pen testing. I have tested it on multiple different servers, and it was very useful. I actually developed it on this exact server. So this PHP Bash link goes to a GitHub page, which has got some malicious PHP on it, which is pretty interesting. And he says he developed it on this server. So that might be kind of a hint that that's what we should look for. If we just look around this website for the rest of the links and stuff, it's not that interesting. So the next thing we do, generally even the next step for any website, is you want to run what's called a directory buster, which basically what that does is it will take a large list of common files and directories that are common on websites, and it will just make request after request after request trying to brute force and find hidden directories. So you can see here we found an images directory, which we don't have a link to normally. We couldn't access it normally, but because we found it and it's publicly facing, we can still access it. We have images, uploads, PHP, CSS, dev, and JavaScript. If we look through all of these, we don't really find that much interesting except for /dev. Remember, he said he developed that malicious PHP on this server, so maybe that's where he keeps it. Lo and behold, that is where he keeps it. So we can click on this phpbash.php, and we can go to that page, and we can use this man's own malicious PHP web shell against himself, which is a little ironic. But so that's step 1 out of the way, reconnaissance. Now it's step 2, initial access, which starts the moment you can run any kind of command on the victim machine. So this is kind of like the motherlode here. Our initial access is a shell, like a full shell, and we can run whatever commands we want. In fact, we can run ifconfig, which is the command that shows you your IP address, and we can double check it's 10.10.10.6.8, which is the same as the IP address we're connecting to, so we know we've broken into that server. So initial access. We can look around on this machine and we can find just about nothing, right? Like we don't really find anything too interesting, nothing like super glaring. So we need to privilege escalate, right? That's the next step in the chain. So what we can do is we can copy over a Linux privilege escalation script that is designed to automatically check for very common Linux misconfigurations and show them to us so that we can exploit them. Kali Linux by default comes with a copy of that lininum.sh. So what we can do is we can copy that over to the directory we're working in, and we can run this command, python tac im simple HTTP server port 80, which is an incredibly useful command. The way it works basically is it starts just a tiny little HTTP server, and whatever you have in that directory, your current working directory, Python will start serving on a website. So anyone can access that website and download whatever files you have, right? So if I'm serving this malicious lininum.sh on this website, then I go over to the wdata bashed web shell that I had. I can use wget, which stands for webget, the IP address of my attacking machine, and then the name of the file I want to download, and I can download that malicious file onto the machine I am trying to break into. So if I download it and I run it, it's going to give me this massive output about potential vectors to privilege escalation. But one of them is much more interesting than the others. This one right here, right? We can sudo without supplying a password, which if you remember from earlier, you always have to sudo with a password. Well, not necessarily always. If you really misconfigure your system, you can make it so that you don't have to. So the more specifics, the user wdata may run the following commands on bashed. So we can run any command we want, that's what this all means, without a password as the user script manager. Now, sudo is super useful, and by default, it lets you run commands as root. But if you specify a different user, you can use sudo to run commands as a user that's not root. So if we use sudo and specify script manager, we can run any command we want as that user. But we have a problem. In order to get a shell, excuse me, in order to get a shell with script manager, we need an interactive session with the victim server. And this web shell is very useful, but it's not interactive. And that's kind of a weird word to say, but basically it's just taking every single command that I execute, and it's executing it on the server, but it's not actually letting me interact with it if it does something more than just execute and output, right? So if I wanted to start an interactive process, it wouldn't let me do that. So we need to create a reverse shell. But what is, I skipped it. What is a reverse shell? Well, it's pretty much what it sounds like. Normally, a client will send a request to the server, right? So if I'm the attacker and I want to get onto the server, I would attack this, or I would request to get onto this server, and I'd find a way to get in normally, right? But if I'm already on the server and I want to get connections to my client through some tricky finagling, I can just tell the server, hey, just ignore all the authentication stuff. Just start running a shell. Just pipe everything in the shell to this guy, right? And I can tell this guy, hey, just sit there and just listen, right? I promise a shell is coming. Just like listen for a shell, and when it shows up, just tell me, right? So instead of asking for a shell, I can just forcefully give myself a shell, if that kind of makes sense. So what do we do? So now I start with this, right? So this NC is short for netcat, and all these commands basically just mean listen, and this means port 8081. So this is start listening on port 8081. That's setting up my listener on this guy. Okay, so I set up my listener, and then I need to actually get the malicious code that is going to start the shell for me, right? So again, by default, Kali Linux comes with one of these, this PHP reverse shell. It's a reverse shell that's written in PHP. So I can copy that whole thing to the same directory where I used my simple Python HTTP server from earlier to get the enumeration script over. I put it in the same directory and do the exact same thing on the victim machine, except for I specify I want the reverse shell.php and not the Linux enumeration.sh. And then once I have that accessed, right, once I have that downloaded, I can execute that with PHP, and immediately my netcat listener just gets a shell, because all it's doing is it's just sending all the raw data of a shell over the internet over to my machine, and I'm just picking it all up. I don't care about authentication or anything. I just get it, right? So you can see I'm running as the www data user right now. I run the command sudo tac u script manager bash. So that means run sudo as the user script manager, run the command bash, and start a new bash shell for me as script manager. And you can see because it's an interactive shell, I can get that return instead of it just being a different process. So now I'm running as script manager, and I can list all the same directories. I can look around a little bit, but the only really interesting thing that happens, or that I see, is this scripts folder. So let's look at what's going on in there. So inside that folder, there are two files, test.py and test.txt. A couple things of note. Test.py is owned by me, and test.txt is owned by root. And if we pay attention to this test.txt, it gets updated every minute, which is pretty interesting because it's owned by root. So that means root is changing this somehow every single minute. Well, let's see what this test.py is, because we have permission to edit it. And what this does is it opens the test.txt file, and it puts testing123 into it, and then it closes the file. So that's really interesting, because if I were to run that as the script manager user, I would execute that, and it would open a test.txt file, but it would be owned by script manager, which means root is executing this Python file once per minute. I'm not sure why, but I don't really care, right? So let's see if we can put something else in that file. Let's see if we can put something malicious in there. What would be something good and malicious to put in there? Well, why not just another reverse shell? If we could run a reverse shell as wdata, why can't we run a reverse shell as root? So if you Google Python reverse shell, this is the very first thing that comes up, and then you can just copy and paste this code over here. You replace the default IP address with the IP address of your attacking Kali Linux machine, and then this specifies which port you want to leave it on. 1, 2, 3, 4, that's fine, we're not using it for anything. So we start up a netcat listener on port 1, 2, 3, 4, and we wait 1 minute. And after a minute, we get a response. And we get a response from the victim IP address. And if we run ID, we can see that our user ID is root, our group ID is root, and we are in the root group, which means we are now root, and we can do, again, literally whatever we want. There are absolutely no roadblocks between us, right? But in front of us right now. So in a normal situation, this would be where we set up persistence. We make some sort of guarantee that we can get back to root access, even if they catch our sneaky little, even if they find this, right? They find this and delete it. We need to set up a way that we can get back in, even if they delete that. And then, and that's the persistence step, right? And then pivot is, all right, once we have the root privileges all set up here, how do we use those privileges to get access to a different machine? And then from there, you kind of repeat the steps. You privesc, and you go back, and then you pivot, and all sorts of stuff. And yeah, so that's a very basic, very beginner kind of hacking exercise, but it teaches you a lot of really interesting concepts that I think are really useful. Yeah, that's all for that. These are my sources if you guys want to look at those. But that's it for my presentations. I'll wait just a little bit. I'll read some of your comments. I'm reading one right now.
Also, a reminder that any of the stuff that he showed you, or that, like, if you go look on YouTube for IPSec or any other stuff, don't do it on a system that you do not own.
Yes.
Have written permission.
Yes, absolutely. We have a lot of stuff on our infrastructure that we allow you to do that with. There are also places like Hack the Box and Try Hack Me. If you want to know more about that, I can tell you about that later. Yeah, this is all exclusively for educational purposes. This is not for you to use in any malicious way whatsoever. Yeah, to answer the question, I mean, Josh kind of answered it correct, like the way I would too, but yeah, most of the basic commands I have memorized, not because I studied, but because I've just done it so long. But if there's anything I don't know, yeah, I use the man page. Yeah. Well, Josh, you said what you had to say, right?
Yep.
Okay. With that, thank you all so much for coming. I understand that times being what they are a bit strange, but I think this went relatively well. I hope you all enjoyed it and learned something new. We're all gonna. I'm at least gonna head to the Discord, and I'll be in the general communications channel there. If you guys communications channel, my brain is fried. If you guys want to go into the general voice channel and ask more questions or just hang out, we're gonna head over there right about now. So I'm gonna stop the stream. Thank you so much for watching, guys, and